thanks for the opportunity. I see some of the people on board this have heard this subject 3 times already, so I hope they can stay awake. So ATOMIC stands for Atlantic Tradewinds Ocean Atmosphere Mesoscale Interaction Campaign. And it's a sort of a U.S. Contribution to a larger international effort, originally started by European groups. Their field program is called Elucidating the Couplings Between Clouds, Convection, and Circulation. And the 4 C's there give it the name Eureka. We pronounce it Eureka, but it's Eureka 4A. So that is a European effort planned off Barbados in the winter of 2020. They are going to use aircraft, ships, and island-based systems. They have an extensive modeling effort, which is actually was one of the major reasons for the field program. The emphasis is on shallow convection and its role in climate models' CO2 warming sensitivity. So they have shown that the sensitivity of the climate models to doubling CO2 is highly correlated with its treatment of shallow convection and how much the shallow convection dries out the boundary layer in warming conditions. And they originally had a very focused aircraft program, and now it's kind of grown. So the Europeans invited a bunch of U.S. scientists in government labs and universities to join in and collaborate on this work, and a couple of us decided to try and push the idea because it sounds pretty interesting. So I'm coming at it from the NOAA angle, and then there's a bunch of university people who are coming at it from their angle. And we want to take advantage of the NOAA observing assets that we can bring to bear and historical collaboration with universities and federal labs. So the emphasis will be on shallow convection also, which overlaps with Eureka, but we'll have much heavier investment in mesoscale coupling with the ocean and aerosol cloud interactions. And there's another effort on the European side is the ocean atmospheric component. So in order to get the ships out there, they have to have oceanographic applications, and so that kind of parallels what we're trying to do to some extent. So shallow convection is a widespread phenomenon over the ocean and over land, so very prevalent in tropics and subtropics, and it's kind of an intermediate state between stratocumulus or highly suppressed boundary layers and deep convection, which deep convection tends to occur in areas with large-scale convergence, where shallow convection would be in sort of large-scale divergence, but weak divergence. And it's involved in climate sensitivity, MJO propagation. There's a lot of shallow convection associated with hurricanes outside of the core of hurricanes, relevant to the intertropical convergence zone. It's the cumulus end of the stratus cumulus transition, and over land it occurs quite often during the daytime. The North Atlantic region we're talking about is a trade wind region, and there's a lot of regional variability. In the winter, you get some. In the winter, the subsidence is fairly strong, but you still get disturbances by fronts and storm tracks and atmospheric rivers. In the summer season, it's more of a mean convergence area, and then you get easterly waves and cyclones and hurricanes and all that kind of thing. It's also, in contrast to the Pacific, it's more influenced by Saharan dust and biomass burning, although that's more stronger in summer than winter. And there's a lot of ocean eddy activity, and the eddies scoop up a lot of fresh water from the big river outputs on the coast of South America. And that leads to a lot of interesting oceanographic issues. So we have a science team made up of university and government lab people. I won't go through this, but it's in NOAA and Navy, and then a bunch of universities. And the list is growing all the time, so it's hard to keep track of. I just wanted to mention that this we have a long history of this NOAA, NSF, ONR major field programs going back to Aztecs, Toga Core, Epic, NAME, Rikka, Vocals, Dynamo, Calwater, the ENRRs, the El Nino Rapid Response Experiment. And the ones in red are non-tropical ones, and they several of them, like Rikka and NAME, feature, and Aztecs feature these shallow convection regimes. So this is sort of the setting for the Eureka atomic domain. The Eureka idea is to fly an aircraft out to this location, fly in a circle like you see over here, and drop radiosondes or dropsondes in the circle, and from that you can compute the convergence and the convective profiles within that circle. And they're going to have a second aircraft that flies sort of at cloud base height, does this kind of sampling, and it looks sideways and measures the cloud properties at cloud base. And that's the key variable and they're interested in this sensitivity of climate. And on the outside of that, they anticipated having ships placed in some kind of a structure like you see here. So BCO is the Barbados Cloud Observatory located on Barbados. And the idea is the ships would be launching radiosondes, which would give you the large-scale subsidence and divergence on a larger scale than this circle, and all these sondes would be assimilated into operational models, and operational models within have very well-defined fields to back up the field program. And then down here's the diagram of percentage of occurrence of ocean eddies, and the ocean eddies are sort of generated on the equatorial region with the shears and undercurrents in that area, and they propagate along South America where they kind of scoop up fresh water, and then they move up right into Barbados, and some of them propagate here along this way, and some get into the Caribbean and grow, and these can find their way into the Gulf of Mexico. And all these eddies in here can also be relevant to hurricane intensity and track when the summer season rolls around. So observational keys, this ship island radiosonde array would give you the forcing on 500 kilometer scales and budgets. The aircraft dropsondes would give you snapshots at about 100 kilometer sail. And then inside that circle, you can measure cloud mass flux statistics, precip coverage, etc. So we are proposing to have a shipborne C-band radar, which would be scanning and be measurements on, say, 50 kilometer radius scale, the forcing and precipitation. On the ship, we would do fluxes and cloud profiling and boundary layer profiling, and we can measure this cloud mass flux property looking up from the ship that the Eureka guys are getting somewhat indirectly by flying at cloud base height. And then the shipboard system can have ocean measurements of turbulence. We can do mesoscale sampling, and we can release all manner of robotic sensors into the ocean, and we can operate a UAV from the ship. So the NOAA effort, I'll just say, our observation assets would be a ship and an aircraft. We could put something on the island, but we don't think that's necessary right now. Within OAR, there's a lot of modeling research going on in clouds, data assimilation, stochastic parameterization, air-sea interaction. And then we're collaborating with NOAA's operational weather. I think to advance the operational models. NOAA's coming out with a new model, and very soon a brand new model, and so there's a lot of effort within OAR on trying to support improving physics in the model, data assimilation, things like that. And so this Rikka atomic data set is expected to be kind of the benchmark data set that models would want to work with for the next 5 or 10 years. So on the NOAA assets, there are 2 aircraft. This is the G4, that's the P3, and then there's the Broad Brown. And on the ship, we can load the ship up with fluxes and radiosondes and mixing measurements, cloud observations, LIDAR, aerosol measurements, the C-band radar. We can operate a UAS. We can throw off robotic sensors. The aircraft, the G4, which is down here, that has a tail Doppler radar and a dropson system. And the P3 is bigger and carries a lot of stuff, so it has a tail Doppler radar. It can drop AXBTs, which measure temperature profiles in the ocean. We can do cloud microphysics. We can drop buoys. We'll put on our W-band cloud radar. It has a radar that measures the ocean wave spectrum. So a lot of possibilities for these aircraft. So we have already requested the ship and the 2 aircraft, and we're pretty optimistic we're going to get all 3 of them. This is just an example of what you can do with dropsons. This shows a line of dropsons, and you can create profiles of humidity and potential temperature and wind speed and direction. This is the same thing but plotted in different kind of colors, I think. So this is a case where you drop a line. If you fly in a circle, then you can compute the divergence and the Q1 and Q2 properties of convection and things like that. And just, the G4 can fly, both the aircraft can fly for like 8 to 10 hours and drop 30 or 40 sons if you can afford to buy that many sons. So this process kind of started for me back in August when I pitched this to right here in Boulder to Physical Science Division where I work, and we got some traction here, and so there was interest here, and it's kind of been moving up the chain. And so I've briefed different groups at CPO and AGU Town Hall we had on this. CLIVAR, one briefing. The Weather Service was briefed by our director. I briefed the OAR Weather Portfolio Group. There was the CLIVAR IAG briefing, the CLIVAR Atlantic Regional Observing Panels. We wrote a white paper and submitted it to CLIVAR International asking for endorsement, which we received. And yesterday, we briefed NSF on possibilities for proposals from university types. So just for your information, There is a white paper. It's reasonably brief, 3 or 4 pages, I've forgotten. And it has both the atomic and this European ocean atmosphere components all integrated together. So that's a nice document if you want to get more details. So we had a meeting in Boulder last week with about 25 participants. So we had general briefing. Bjorn Stevens gave a general briefing, and we heard from people within NOAA and NRL and university communities. We had a pretty strong showing from AOML, which is the Atlantic Lab in Miami, and they already operate out in this part of the world and have a lot of things going on. And they're interested in collaborating on this. We also heard from the Pacific Marine Laboratory in Washington. They're interested in cooperating in the observations. And then we heard from several modeling groups, 2 within NOAA, and then we also heard from the NRL modeling group. So there's a lot of interest in modeling groups in working with us on improving the models. And then there was a lot of discussion of university types about what could we do given a ship and aircraft support and all this infrastructure in here. And so they developed kind of a general plan on I'm going to say, unique study of mesoscale variability in the ocean, a Lagrangian study based on robotic sensors. So several of these groups have their own sensors that they've been developing and deploying over the last few decades. So we're talking about throwing over spar buoys that measure fluxes in the air and then stick down in the ocean and measure turbulence in the ocean. The group from Applied Physics Lab can throw 15 of these things over. They also measure the waves. There's a couple of automated systems called wave gliders where they do something similar. They're larger, and then they're steered around. They use the waves to actually create the energy to move the thing around so they can tell it where to go. And there's several other robotic systems like these so-called ocean gliders, which kind of move around underneath. And then there's Argo-type profiling systems, and there's a type of those Argo profilers that can be dropped out of the P3. So the vision here is to have a big Lagrangian array of all these sensors dropped off probably down in here somewhere, and then it would drift this way, and then the ships can collect and redeploy them as necessary. So one idea is to target a big ocean eddy if there's one in this region. And that's said to be about a 50% probability that one of these eddies here would be in the right place. And if there's not an eddy, there's other kinds of ocean variability. And then another thing we would do would spend time over here by this buoy. This is a buoy that NOAA funds Woods Hole to operate. It's called the North Tropical Atlantic Station Buoy. That's a atmospheric flux reference site, and it has a large contingent of instruments subsurface that are measuring profiles in the ocean of temperature, salinity, currents, and things like that. And it's been there for like 12 years or something. So we have a huge climatology almost of data there. And it's used a lot for looking at how well models are balancing their budgets and how well are they resolving the ocean structures, and also used for satellite in comparison. So this is a very valuable asset out here. And it's also upwind of the action in the Eureka part of this domain. So observations out here will be helpful as the structures here kind of drift through there. So this is just a proposed track on here that we came out of our discussions with the group here in Boulder. And so another aspect of this is we have not hammered out the details of how we're going to work with Eureka on this. They are going to be flying their aircraft, doing these circles and concentrating on that domain. And of course, they'll fly 3 days a week, Monday, Wednesday, Friday. So in principle, we could supplement that by flying a couple of days a week with the G4. And I would like to do that at least for 1 week and get a full 5 or 6 day time series without any holes in it. But right now our thinking is that the P3 would principally support the Ron Brown and the oceanographic efforts. The G4 would be a mixture. So summary, we're working within NOAA for a major effort, and I'm pretty optimistic about that. We've gotten lots of positive feedback from the NOAA labs and from NOAA OAR management, and the Weather Service is interested in working with us on this. NOAA has a brand new model, so the timing is perfect for that. So and that looks good, and we've gotten pretty good university interest. It looks like maybe 6 or so proposals could be submitted to NSF, maybe by the August 15 timeframe. We're coordinating with other U.S. government labs right now, principally with Naval Research Lab, which is one of our longtime partners in this kind of work. And close coordinated with EU would be in the future when a little bit of the fog clears on what we're going to do. So with that, I'll conclude and take any questions.